Hello everybody, this is Introductory Physics Lab 3. In this lab we are going to analyze the movement of a star that is orbiting a black hole of unknown mass. So what causes this movement? In our case, the gravitational force only from the black hole on the star. We treat this problem as a two-dimensional problem where is given x and y coordinates of the star's position. As we see, we have one observation per day. Furthermore, we know black hole's position. So let's try to find black hole's mass. The gravitational force is given from this equation. Fg is the force between the masses, gravitational constant is known, mass of the star is given, mass of the black hole is what we are looking, r hat is the unit vector, and r is the distance between the center of the masses. Actually, r is given at any point from this equation. So to sum up, we know the motion but not the force, or better, we know that there is only the gravitational force, but we don't know the magnitude. So let's use the derivative form of Newton's second law. We assume that delta t is small, so F net is given from this equation. From the first two position data points, we can estimate a velocity. From second and third position data, we obtain another velocity. So we have two velocities and therefore one change of velocity. We then calculate a change of momentum, and when we divide this by delta t, we obtain the first estimate of net force. F net has this value, but in our system there is only the gravitational force. So Fg is equal to this value 2. From gravitational equation, and after doing some math, we can estimate m. We just found Fg, g is known, m is given, and r is actually given from this equation. The star has initial velocity and momentum here, and at this point the gravitational force causes a change of velocity and momentum. Taking all this into account, we obtain black hole's mass, and as we see here, this value is equal to the value I obtained from Python. So now let's open Python. Okay, the code. Here's the mass of the star, here's delta t in seconds. Here I read the observations from my CSV file, and here's the first while loop. Let's take a closer look of this while loop. So actually this while loop does what I did right here, but I did it only for my first three observations. The while loop does it for all the observations, and you can see here the similarities. Okay, next there is another while loop. This while loop does some more calculations for all the observations. I did these calculations for only the first three observations. The initial in my case is V1, the final is V2, the initial, the final, delta V is right here, delta P is right here, and F net is given from this equation. Let's do some more physics. I assume that delta t is small, so F net is given from this form. Momentum is given from this equation. If I combine these two equations, I get this form for F net. Again, I assume delta t, once more I assumed delta t small, so I can this part is transformed to this form. I know V2 and therefore P2 and therefore its magnitude, the same for P1, and this code does these equations, calculates this equation. So I find dPdt parallel right here. Okay, I find dPdt right here, and if I subtract this part from this part, I get dPdt perpendicular right here. Let's run Python and see the result. This is the black hole, this is the star, and the yellow arrow is the vector of the gravitational force, and it's pointing always to the black hole, as expected. What does it mean? dPdt parallel describes if an object speeds up or slows down. dPdt perpendicular describes the curvature of an object. dPdt is the combination of curving and speeding up or slowing down movement. On the other hand, F net parallel is the force that causes the speeding up or slowing down. F net perpendicular is the force that causes the curvature, and F net is the combination of the above causes. So dPdt describes the motion, but F net describes the cause. What if, let's assume that we move our black hole and in the same position is placed another one with unknown mass. This is the only change. So G is constant, same trajectory, and the new black hole to the same position, therefore R is the same. The mass of the star is the same, M the same. Same trajectory, same motion, therefore dP the same, and as a result F net the same. That means Fg the same. So from gravitational force, from equation for the gravitational force, all these parameters are the same. So M must be the same. In other words, the mass of the new black hole must have the same value as before, as the old black hole. Thank you very much.